Okay, guys, so let's start. So yesterday we have done the one small one practical of IPsec. Okay, and that time we have captured the packets and we have discussed how exactly they would exchange and all right. So everything we have seen. So today we are going to be started, and today's main topic is about headers. The main target for this is header set. So first of all, would we would start with the ISACAMP header. Okay, so the size of ISACAMP header is 28 bytes. Okay, and how it looks like. So this is the header. So the size of the header would be 28 bytes overall. The total size, initiator SPI, responder and means destination SPI. Then we would have one next payload here, minimum version, maximum version, exchange type, and flag. Okay, and then we would have message ID and then length. Okay, so this is about initiator SPI here, and its size would be 8 bytes. This is responder SPI, and its size would be again 8 bytes. This is next payload. Okay, so this is 1 octet, or you can say this is a 1 byte here. This is the minimum version. This is the maximum version. And this size is 4 bits. This is 4 bits. And this is again 4 bits. Okay. And then this is exchange types. Then we have flag here. So this is again 1 byte. This is again 1 byte here. And then we have message ID. The size is 4 bytes. And then there's a length. We'll put out again. Bytes. Okay. So overall, like you can say, 8 plus 16, 17, 18, 19, 20, 24, 28. So total size is 28 bytes. Okay, guys. So this is the header we have as a header. Okay. So along with that, we would capture some packets today. So let me just get back to let me open my the same topologies. So exactly 106. Just wait for a minute. Let it be start. So guys, yesterday, this was my topology which I was using it like between site A and site B. Okay, and let's consider over that we have this is connected over the ISP, and we are connected like this. And we have configured one VPN, IPsec tunnel, or we can say the VPN onto this. Okay. So as per this site, from here, guys, how many tunnels and how many VPNs do we have right now, currently? How many PS are active? Yes, guys. Am I audible or not? So from site A, right now, how many of peers and how many of tunnels are active right now?
One.
One
One.
on one, right?
Yes, sir.
For
Yes.
example, let's consider if we have multiple sites. Let's consider this is one site here, site A, and this is connected over the ISP with the multiple sites. Like multiple sites means site B, then site C, and then about the site D here. Okay, so we have it's connected like this. Okay, obviously they are connected over the ISP with each other. Okay, we have ISP and they're connected over the ISP, and after that we have directly tunnel between them. Okay, so if this is one of the VPN like IPsec tunnel, for example, we have created here. After that, we have created one IPsec tunnel with this. Okay, and that's just, and then again one IPsec tunnel with this. So from site A, guys, how many tunnels do we have? From
Three.
tunnel, three. Okay, so we have three VPNs here. You can say three IPsec tunnel right now. Three IPsec tunnel I'm using. And as you know, in the IPsec, okay, so overall it would exchange total how many messages it would exchange? This side would exchange 9 messages with this, 9 messages with this, and 9 message with this. So total overall, side A is going to be exchanged how many messages? 27. Okay, 27 messages. Now, when a side A would negotiate with the side B, okay, and when it would negotiate with the night side C, and when it would negotiate with the D here. So every time we would have a different Diffie Hellman, different Diffie Hellman here, different Diffie Hellman here, different Diffie Hellman here. So this side would have different like three king materials here. What it would have? Three king materials. So this is, let's consider the king material, or we can say the keys for side A. This is for the side B, and this is for the side C here, for example. Okay, this is the king material of site A. This is about of site B, and this is about site C here. Okay, now, so I think my devices have been started. Now the question is, so see, let it be open. I think it's started. Started, yes. So I need the face brief. Interface is the down state. Interface is a slash 0. No shell. Here again. Page. Before that, just let me enable the captures here once. Ping with 11.1.1.1.2, which is a public IP, it's fine. And now ping with 2.2.2.2 as a source of 1.1.1. Fine. So crypto, IP set. Yes. Okay. Packets are getting encrypted. And as you can see, we have changed the line messages. Okay. And ICMP, so it means AH we are using right now. All here. Okay. So now, what would be there? What would be the concept here? These key materials. Okay, the question is, let's consider. Now consider this site is sending some data. This is some data here, and which is already encrypted, and this data is sending towards where, and which is encrypted into the site B. Let's consider this at the same time. What is this is one, this is another. Okay, and they're sending the data where? They're sending the data towards site A. This is from site A, and this is again towards site A. Okay, from where? From the site B, C, and D. And this data is already encrypted. So site A has to decrypt this data here. So that time the site A has to like immediately identify key like this data is coming from where and which keying material and which keys should I use to decrypt the data. Are you getting my point, guys? Okay, I'm just repeating it again. Kindly listen carefully. I'm saying when site B and site C is sending some encrypted data towards site A, and now site A has to decrypt it. So that time site A would have a question, okay, like I have received three different, like three encrypted packets, but I'm not sure is this from the which tunnel? Okay, is it this for the which interface? Because we do not have any tunnel interfaces here. Okay, because all these three tunnels are active on the same site here on the same crypto, all the three crypto map we have called where? We have called on the same interface itself. So the question is, how I would be able to identify during the decryption, which keying material should I use it? So for that, we have the concept about SPI. That's the reason we have the concept about SPI here. So as we have seen earlier, okay, there would be initiator SPI and sender SPI, right? So let's consider in this tunnel here, initiator SPI. Initiator SPI is about, for example, consider 1, 2, 3. Okay, and after that, responder SPI is 4, 5, 6. This is after the all the 9 message exchange I'm talking about. They have decided everything is fine. This time they have something like, consider it 895, and this is about 452, consider it. And this side again, initiator SPI, this is about 852, and this is considered 125 here. Okay, so on each and every, for each and every tunnel, there would be a the different SPI. Okay, as you know how they would calculate the SPI, they would use source IP, destination IP, source port, destination port, and along with that, timestamp. So obviously, the SPI values of two tunnels cannot be same first of all. Okay, that would be always different. The reason, because this tunnel has a source point can be same, but each and every tunnel has a different destination. So definitely the same port, like same SPI cannot be possible. So let's consider here they have decided that this is the SPI, this is the SPI, and this is the SPI. So when all these three packets would reach at the same time, okay, on this side A, then side A would check it first of all, what is the initiator SPI and responder SPI. Let's consider the site is first opening this packet here, and in that it would check it what is exactly the initiator SPI 895 and this is 452. Okay, so then it would check in its database, and after that it would get to know, okay, this data is from the which tunnel, for the tunnel number 2, from the this tunnel here, and which keying material should I use it? I should use this particular keying. Okay, so the overall question is, in the previous class, we have discussed what is SPI, right? Initiator SPI, responder SPI, how it would calculate. but we haven't discussed why it's going to be used. So now today answer is it would be able to differentiate. Okay, so you can say site A or any particular site A, if has a multiple tunnel, okay, then that particular site would use SPI value to identify the incoming traffic from the specific tunnel. So this is the use of initiator SPI. When a site is having a single tunnel, then it's fine, but still it would use the SPI. Okay, but in this scenario, we cannot say exactly the use of SPI. When it would be there, when it from the single branch to single site, if we have multiple tunnels, okay, so then your SPI would help you into the same. Okay, yes, guys, is this clear or not? Yes, guys, is this clear or not? I'm
Yes,
waiting for
clear.
an answer. What about other guys?
Yes, sir.
I hope everyone is there.
Yes, yes.
Clear, right? So this is the SPI. So if I'll talk about the size of SPI is about 8 bytes here, and this is the 8 bytes. So we have seen it earlier in the this one. So let's consider talk about here, not here into the not into this, because as it can be used during the handshake only, right? So let me just go back up, and this is so this is initiator as a camp header, and here this is my initiator SPI, and why my responder SPI is 00 here, because this is my message number 1. Okay, so from the message second onwards, okay, here again there would be some value. Okay, because who would calculate the responder SPI? Only responder device would calculate the responder SPI. Okay, so this is guys initiator SPI and responder SPIs. Okay, now the next we have next concept is next payload. What is that? That is next payload. Next payload term would explain us exactly which is the next header, which is the next header here. There is there is a possibilities. What are the possibilities? So see in the first first thing is there are three possibility. One is security association. Second is key exchange. Okay, and third is about your DeFi help. Not DeFi help. Sorry, authentication and all their identification. Most of time there would be identification. So these are the three possibilities in this header. Okay, we have three possibilities into this. So what are the possibilities? How? So guys, in the first and second message, if I'll talk about in the first and second message, what concept, what we are going to be exchanged guys here in the first and second message? Yes, guys, what we are going to be exchange?
Yes, sir.
Essays. We are going to exchange essays here, okay? Like Haggle. So this concept is for this essays here. And as you can see here in this message, what is that? Next payload is security association. So first and second message. Okay, so if I'll talk about in first and this is my second message. In second message also it's what now? What is the next payload? This is security association. But if I'll get in to the third one. So third one is not about security association. Third is all about key exchange, because as you know, the first and second message is all about essays, but third and fourth message is all about what? Key exchange. This is all about what? Key exchange. Okay, which is about DeFi. And now fifth and sixth message is all about what, guys? Fifth and sixth message. Okay, so this is all about identity. Identity and authentication. Okay, so but in the messages, we can see their identification would be mentioned, not the authentication. So if I'll be back here, so fifth is about identification and sixth message again, identification. And if you would talk about in the seventh message, okay, what is there? Hash. Yeah, one more possibility here, which is about fourth is hash. Okay, hash means which algorithms we are going to be using to the transform setting. Okay, so but after that, as you know, and like here we can see if that is all about hash here, that fine we can see here in the next payload would value would be hash, but we won't be able to open anything. The reason is because data has been encrypted here. Because which packet onwards, guys, actual encryption would start? Can you tell me?
Packet.
Sorry,
Fifth packet. Fifth message.
fifth message. What about other guys? Hardly like Srini and one more, two guys are only responding. What about others? Are you there or not? Just logged in and just left. I hope everyone is there.
Yes, sir.
Yes, sir.
Yeah. So in case if you're not able to speak, no problem. At least answer in the chat box. Okay.
Okay.
So this is about like no fifth packet onwards here, right? So here onwards, everything would be encrypted. Okay. So this concept is about, guys, next payload is about all this three here. This ISACamp header is important for the interview perspective. Okay, obviously in exam there is no use of that, but yes, it would be very important for what? It would be important for the your interviews there. Okay, in interviews they can ask you about, okay, what is the initiator SPI, what is the size of initiator SPI, what is the total size of ISACamp header? Because most of time during the VPN, we would always discuss headers. Headers is the important concept here. Okay, when we are using GRE, so what is the size of the GRE header? That is a 4 byte. How many byte of let's consider, guys, if I'll talk about in GRE, okay, GRE we have already discussed, okay. So if we are talking about the GRE, in the GRE, how many bytes of header we use? In GRE, we use the 4 bytes for GRE, 20 bytes for IP. So total is what? 24 bytes here. On top of that, we have to use then IPsec. So IPsec would add how many bytes of header? So it would add 20 bytes of header again of ISACamp. And after that, this is just during the handshake. But after that, there would be data exchange. So in the data exchange, we would use what? ESP. So what is the size of the ESP header? ESP header again would add some outer header and also those concepts. So headers would plays very important role into this. So today that's the reason I'm just discussing here what headers only, the size of headers and what exactly the headers, why we need it, okay, and what is the use and what is the meaning of the headers into this. Okay. So this is the payload here. After that, the next concept, okay, and what is the size of the payload here? This is the size of this field is 1 byte. Okay. Next we have minimum version. What is the minimum version here? IKV2 version. This is it's about IKE versions they are talking about. Okay, IKE has 3 versions actually. This is about version 0, then 1, and then not here. Just let me mention here. It has 3 versions. One is 0, one is 1, one is 2. 0 was for the testing purpose. We didn't use, but we use what IKV1 and IKV2 here. So if we are using IKV1, So your IK, so that time, this is just for the 4-bit. So 1, 2, 3, 4. So if in the minimum version, this is the minimum version here. And in the maximum version, what would be there? Maximum version is which version of IK are you using it? Let's consider right now I'm using IK version 1. So what would be their value? This would be the value because this is for the what? Version 1. And if I talk about version 2 in the upcoming classes, then it would be looks like this. Okay, so this value. So in the minimum value, this is the minimum value here. Okay, and this is always remain 000. But maximum version can be changed depends on which current version of IK are you using it. So if you're using is version 1, so then it would be 001. And if you're using version 2, then it would be 0010. We'll check it out now here. Just I'll be back and let's open the first message. And you can see this is the after security next payload, we have versions. Okay, so which version? So version, this is the minimum version is always 000 and major version is what? 001. Okay, because this is if you would and this is the size is 4-bit only, right? This is the reason we are using 4 bits. And if you would convert it, so then 4-bit is for this and 4-bit is for this. So overall 1 byte, but internally it's divided into 2 parts. This is the 1 and this is the 2. So 1 is the minimum version of 4 byte and this is the maximum major version, or you can say maximum version of 4 bytes. So 4 bits, I'm talking about. So total it would become 1 byte here. So this is 4-bit and this is again 4-bit. And that would become 8 bits and 1 byte. Okay. Guys, this is, I hope this is clear. This is the version. Next concept we have here. The next concept is exchange type. Okay, what is that? Exchange type. Exchange type has a 3 options. Okay, it has 3 options. The first option is main mode, then we have aggressive mode, and then quick mode. So this is the option for the main mode here. The main mode, or as you know, then aggressive mode, and then about. Okay, what is size? 1 byte here. So I'll take you back. So you know, as the first 6 messages is all about the main mode here, as we can see here itself. But if you would get into the inside the packet message or packet, so as we can see here, after version, what is the exchange type? Main mode. And this concept is known as identity protection here. Okay, the another name of main mode is, you can say, identity protection. So till where this identity protection will be, this is again identity protection here. Diffie-Hellman, same again this main mode. This is again same identity protection here, and quick mode is again this is a quick mode. So it means, guys, the main mode is also known as, or in the headers, what would be their identity protection. So the main mode, one extra, what another name would be named like would be mentioned as a identity protection. Okay, but for quick mode, we do not have any other names. Okay, this is just a simple quick mode we have. Okay, same with this, again we have quick mode. So this is about the 3 things here. Okay, so this is about your main mode, aggressive mode, and quick mode. So till now, guys, we have discussed about SPI. One is the initiator, then responder, then we discuss next payload, minimum version, maximum version, and exchange type. Up to here, guys, do you have any doubt, any questions? Anyone? I'm waiting for your reply. Okay, fine. Next we have flag. So there are the three different kind of flags out there. Okay. So one is authentication. Second is commit. Okay. And one is for encrypted. Okay. So we have a three option into this: authentication, encryption, and commit. Okay. So as we can see, this flag here. So flag, and you can see we have three flags. Encryption, no encryption, not encrypted, commit, no commitment, and this is no authentication. So this is actually about this, but exactly in the front of that, what has they have mentioned not, and not here. What is the meaning of this? See, authentication and encryption. So I hope everybody knows what is the meaning of commit. That is important here. The commit concept is, guys, let's consider we have two sites, site A and site B. Both are connected. On top of that, we have used a VPN. VPN right now, my IPsec VPN, that is up. Okay. IPsec VPN here. Okay, everything is up right now. So IPsec is up. Let's consider, I'm just talking about as per the phase 2. So guys, tell me for how long this phase 2 would be enabled. Tell me the phase 2, how long it would be enabled or it would be up. Yes, guys, for how long this phase 2 would be enabled or up? Tell me. Okay, what about others? Only one reply out of 17. Correct. This is for the what? This is for the 1 hour. Okay. 3600 seconds. Right? Correct. So this is for 1 hour, or you can say 3600 seconds. Let's consider till now at a time at the 10 minutes, after 10 minutes, post 10 minutes. So post 10 minutes, what happened? Let's consider because of some technical problem. Okay. This router went down. This is what? This is right now down because of some technical problem and whatever. Okay. This is down. So what next now? Because this is already down here and this is not able to communicate, everything is fine. But next time, let's consider after this and its downtime is just 5 minutes. What are the downtime? Downtime is just a 5 minutes. But we have already saved all the configuration. What is saved? We have saved all the configuration. After 5 minutes, this side would be up. This is what? This is up now. Okay. So again, communication, everything is fine. And this side is sending some data. Let's consider. Okay, via its IPsec. Okay, this is what? This is what in the form of what? This is in the form of encryption. This is encrypted packet. So guys, see, tell me, last time this device was up earlier and the time T0, both the devices were up. Okay, and we have configured the tunnel and they would be able to exchange and they would be able to do the encryption and decryption on the both the sides and everything was fine. But right now, what is the problem? Okay, the problem is some time back, this site went down. The site is down. Okay, right. So now the next one is after 5 minutes when this device came up. So this device is getting what? Encrypted packets. So this device is saying last time I was here, But what, like I was up, but that time the tunnel was up and everything was fine. But right now, what is the problem I'm facing? I'm not able to decrypt this packet. But on this device, on the interface, we have already configured everything. We have crypto map and everything is fine. So what device, this device would send it? Because this device want to resume its previous session. Okay, it would resume the what? Previous session. This device knows about everything. But what is the main problem here? The keying material. Because if this device went down, okay, so this device would what? Like you can say lost its your keying material. Because keying material is always into the temporary memory here. That won't be saved into the flash. That would be the always the part of what? NVRAM. Okay. And as you know, NVRAM is always temporary. Okay. But other configuration we have saved, and that is still into where? That is still into the flash. Okay. So what happened here? When the next time this device would be up, and after that, if this device would get the encrypted packet, okay, then it would check in database ki, okay, I'm getting this encrypted data. But with the help of the headers, I can see this is like I'm getting from one of my peer, which was enabled last time. So what happened? This device would send one commit bit to this. Commit bit, and in the commit bit, it would mention 1. In the commit bit, what it would mention? It would mention 1. Commit bit means key. I have the information about message 1 and message 2. Means earlier we have already negotiated on what? Negotiated on haggle. So no need to exchange first and second message again. Okay. 7th and 8th and 9th. These messages are again no need to exchange because I have already ESP information. Authentication again, that is not needed. Okay, what is needed here? Defi help, because my previous keying material was saved in the what? That was saved in my NVRAM. So this time I do not have any keying material, and because I'm missing, I do not have a keying material, but I have the algorithm, so I'm not able to decrypt the packets. So let's do one thing. Let's exchange the keying material again. So again, only Diffie-Hellman messages would be exchanged between both the sides. So this is the use of the commit bit. So instead of exchanging 9 messages, only how many messages we are going to be exchanged? Just 2 messages. So this is the use of the commit bit. Yes, guys. Any doubt, any questions into this? I hope this is clear. Anyone want to ask any questions, anything, anyone? All clear? Pawan, Anu, Bennett, Benita, Santosh, I hope all clear? Okay. Okay. So this is the use of commit. Next. Next, message ID. Message ID is what? Message ID is kind of, not exactly, but message ID is kind of SPI for phase 2. Okay. It would be activate, okay, during phase 2. Okay. As it now, I will see the message number 1, which is phase 1, and after the flag message ID is 0. Okay. This is here again, message ID 0. And if I'll show the last message of the phase 1, again, message ID is 0. But if I'll talk about quick mode, okay, the quick mode, the message ID is what? Again, it would have some value. So there's some internal algorithms and all they would use it. And with the help of this, they would calculate the message ID. So message ID is just kind of, you can say just not exactly the SPI, but kind of, okay? Because earlier we have discussed about SPIs and all. So message ID would be valid for the what? For the phase 2. Okay, and it would be always activated during the phase 2, not during the phase 1. Next, we have length. What is the length? So this is the total length of the you had about your. This is just a 172. This 172 doesn't mean that this is the size of your ASICAMP header, because ASICAMP header size is overall 28 bytes. So this is the overall size of your packet. Okay, and this is after that we have. So up to length, this is my ASICAMP. And total size is 28 bytes. Very, very important for internet. Okay, because if someone would start asking the question from the IP side, so first of all, they would talk about message exchange and all these kind of things there. But later, once let's consider you are explaining and your explanation towards your message exchange is good, okay, and if they are just looking for someone who's good into the VPN and all. So after that, they would start digging ASICAMP header. It's most of the time they won't ask you about ESP and about AH header. Okay, but yes, ESP header is very okay. So try this is likely your TCP header and IP header. These are some header which is very important for the interview, like TCP, then UDP, then IP, and now and one more header in the list, and that is ASICAMP. I'll not ask you, no, you have to go through other headers also, which is very important and all. No. That's fine. Okay, that would work. Okay, but without ASICAMP, that is very difficult. Okay. Now, so this is all about ASICAMP. Next, we have AH. Size is 16 bytes. Okay. So what exactly the header? The first thing, this is about, I think this would be small. So first of all, here, there would be information about next header. Okay. Next header, this information is about payload length. Then this is reserved for the future actually. Reserved for the future. Then we have AHSPI. Okay. And this is we have a sequence number. And this is authentication. This is kind of your, this is also known as kind of ICV. Okay, ICV, which is about integrated checksum value. Okay, because what exactly authentication does, guys? Just only integrating. So this is that data. So next payload header, okay, overall size is about 16 bits. So it's this is about 1 byte. Overall size is about here 8 bits. You can see the 1 byte here. The next is also this is a payload. This is also, I think, 1 byte only. This is also 1 byte. Yes, this is for the 2 bytes. Yeah, correct. This is 2 byte. This is again 4 bytes this time. And this is also 4 bytes. Okay, and this is also 4 bytes. Okay. So you can see this is 4 plus 8, 12, 14, 15, 16. So overall size is 16. So this is authentication header. So this is about the main concept is next payload. What exactly the next payload here? So see next, what is the meaning of next payload? So as you can see headers, how exactly authentication header would be there? Let's consider between two sites, I have pinged. Let's consider just now we have pinged here. Okay. So what exactly would be there? So let's consider this is my 11.1 here. This is about 11.2. And here I'm using LAN A, LAN B, and this is about 1.1.1.1, and this would be 2.2.2.2. And let's consider I have ping from here as a 2.2.2 to the source server 1.1.1. Okay, so what happens the next? The next concept here, first of all, there would be this as headers. Let's consider this as headers here. These are the header informations. First of all, let's talk about the system. So we have ICMP first of all. This is ICMP data. Then we have ICMP, then we have IP address system. So this is about ICMP data here. This is all about ICMP data. This is about ICMP header. This is header, and then we have source IP and destination. So this is about my IP. So here there would be source IP, and then there would be destination IP. So what exactly the source IP guys here? Actual 1.1.1, and what is for this? 2.2. Okay. On top of that, then there would be authentication header. This is what which header here? Authentication header. After authentication header, on top of that, there would be again one more header. This is about your outer header. Okay. This is again, we have source IP, and this is we have destination IP here. And what would be this source IP here? Okay. So it would be 11.1 and it would be 11. See, ICMP. So let's talk about from the down. This is ICMP header. Okay, inside that we have ICMP data and all. Okay, that's fine. So this is ICMP. This is IP. This is I'm talking about here. See, as I have mentioned here. So now, first of all, what? So here, as I can see, first of all, this is ICMP, the ICMP data and ICMP header. So this information into data inside the ICMP header, and then we have ICMP. After that, we have IP header, which is 1.1 and 2.2, actual source and destination. This is 1.1, this is 2.2 here. Then we have authentication header. This is authentication header, and on top of that, we have outer header, which is 11.1 and 11.2. So this is 11.1 and 11.2. Yes, guys. I hope this is clear. Any doubt or any questions up to this? But if we will talk about ESP, if we will talk about here ESP. So in ESP, what happened? In ESP, it would be the same concept. Just here, it would be the ESP header. What would be there? Here it would be ESP header, and in ESP header, this data would be here onwards. Everything would be encrypted. Are you getting my point, guys? Up to here, it's clear or not? Because data is what? Data is into the which format? That would be into the encrypted format. Yes, is this clear or not? Waiting for the reply. Yes, guys, is this clear? Okay. Okay. So now we have to talk about what these headers here. Okay, so what is the header size of this? This is is 16 bytes. This is what? 16 bytes. So let's talk about the header. So next header. So you can see now when we talk about every, and as this information you know, every lower layer, like a lower layer like headers has a upper layer information. So what exactly this is? Authentication header. So in this authentication header, there would be the information about the next header. So practically we'll check it out here. This is my AH header here. So AH header, next header is what? Next header is my IP header here. So what will be the information? IP. What is that? That is IP and IP. Okay. So this is information is into what? This is into the information about your IPv4. Length, this is the length of the header. Then reserved for the future. AH SPI, they have calculated again SPI. This is for the AH only. This is ICV, that your result of your, can say, the checksum value and the sequence number. What is the meaning of the sequence number? So the sequence number means, okay, key, let's consider between both the sides, we have started exchanging the data. Okay, so when, let's consider first of all 9 message exchange, everything has been done. My tunnel is up, the phase 1 is up and phase 1 is down. After that, this is my first data. This is my what? Packet 1, or you can say data 1. After that, the next would be your data 2. Next packet would be data 2. That concept is known as now data 2 there. So if you are using ESP or AH, whatever, in ESP also we'll talk about that. Okay. So there we would have like sequence number. Like in TCP, you remember we have sequence number. Okay. So like always with each and every packet, there would be a sequence number and all. Okay. So same here, this is kind of authentication header number, you can see. So the first packet with the first packet, this is AH sequence number. What would be the first packet here? Packet number 1. With the second one, the value would be what? AH. Now I'll show you. So see, this is my first packet which I have opened, ego request. And what is my authentication value? AH sequence number 1. But second is what? Echo reply. This is also will remain 1 because this is a reply for that. But if you would talk about request here, this is the second request. So the packet number is what? 2. What is the sequence number? 2. What is that? We will just check the request only. And as you know, when we would ping, so it would generate always 5 packets. So this is the next sequence number 3. And this is again request sequence number 4. So this is the sequence number of the data. Okay. Further also have we pinged ever? No, this we have not pinged. And if you ping it again, okay, ping with 2.2.2. Okay, actually I have disabled this caption. Let me just enable the captures here again. I would ping as also 1.1. Okay, and if you would open it, this is the request. And this time, as you can see, sequence. Last sequence number was 4, right? And now sequence number is 5. Same with ESP. Okay. How we have to configure the ESP? Let's consider the site A, crypto, IPsec, transform set, tsec, ESP, 3- ESP, MD5. This is for site A. This is site B here. has been done. And now if I'll be back here, clear crypto. Guys, if I want to check it out, which is my active peer here, okay, which connection ID? What is the command for that? I hope you have practiced all this, right? Yesterday? Yes, guys. Have you practiced IPsec or not? I hope everybody has practiced, right? So now clear crypto caching. Okay. And now again, we'll just generate the packets 2.2.2 as a source of 1.1. Okay. We have generated it. And if I'll be back here, and this is ESP. And ESP, if you will open it, you can see. See, up to here, so we have 9 message exchange. But as you can count it here, this is the first request here. And if you would open it, ESP1. If you would open the second, this is again the reply. But if you would check the third one, so this is the request and this is sequence number. So this is again we have in ESP, we have SPI, and then we have sequence number. And after that, everything is encrypted, so we cannot see anything. Right? So this is guys ESPN, EH. Okay. So these are the sequence number and these are the SPIs. Okay. So this is, you can see this is my sequence number 2. This is sequence number 3. Okay. This is sequence number 4. And which SPI we are using it? 210. In the request, we have SPI as a 2010 in the land, you can say 2010 here. And from the another side, it's about what? 771. Okay. This is 210. And in the reply, we have what? 877. Clear, guys? So this is the concept about what? This is the concept about where address. So show crypto IPsec. Sorry. See guys. Now we have, see this is we have discussed, okay. This is the output of what? Your crypto IPsec essay. Okay. So this concept is also known as SPD. Okay. This is a security policy database. So this is SPD and let's show crypto as I can. What happened? As it can. This is known as SAD here, Security Association Database, and this concept is known as Security Policy Database as well. So you can see this crypto IPsec, this is enabled on which interface? Z0/0 interface. What is the crypto map we are using it? IMAP. In the configuration, we have only configured what would be my crypto map. We have mentioned it IMAP here. Local address is what? 11.1 because this is about myself. After that, are you using any VRF concept into this? No, I'm not using any VRF. What is the local identity? That's about 1.1.1. This. And what is the remote identity? So this is, guys, the address. This is about interesting traffic. You remember inside A, this is my side A, this is my side B. And here I'm using 1.1.1.1. And on the another side, we are using what? 2.2.2.2 here. So what is the local identity here? Local identity is about we have mentioned 1. See, I have used the ACL. In ACL, in extended ACL, even I can mention source IP, destination IP, I can mention which protocol. Because see, right now in the IPsec tunnel, we have just mentioned that if any kind of traffic is getting generated from between these two networks or the LANs, that should be passed through the like IPsec tunnel. Because in ACL, we have mentioned a term about IP. As you can see here, I'll show you. Show run section. Okay, because in access list, we have mentioned which word? IP. Okay, so but let's consider instead of IP, I'm asking you guys, if you are using, okay, or if you're exchanging any unsecured data like 80 and 23 port number in TCP here. This is about HTTP and this is about Telnet. So that time only you have to use IPsec tunnel. So that time in the ACL, we have to mention ourselves instead of using right now what I have mentioned, right now I have mentioned this one. Okay. So instead of this, okay. So this is the right now ACL what I am using it. Okay. So instead of this, what we have to use it there, we have to use access list 101 permit TCP. Source would remain same and equals to 20. So this should be the first entry, okay, and then this should be the second entry. And when you would mention this entries here, after that, this information would be updated. Right now, this is a local client and remote client here, this information. So right now, this information is about what? Address is what? This is the address they have mentioned. Mask is what? Mask they have mentioned. What are the which protocol and which port number? They have not mentioned anything. The reason because IP is for all. But in case if you would use for 23 and 24, then here they would mention protocol 6 and one port number 23. And in the down the second one would mention protocol 6 and port number 8. So this would be the output if you define your two ACLs just for TCP telnet or HTTP traffic instead of using IP. Yes, guys. Is this clear or no? Yes, guys, this concept is clear. Local identity and remote identity here. Yes, guys, is this clear or not? The local and the remote identity. Yes, please.
Yes, sir. Yes, sir.
Clear? Okay. Okay. After that, who's the current peer? Current peer we have only defined, which is about 11.2 and port number 500. Okay. The permit ACLs and all note now because we haven't covered this concept. These are the packets counts here. How many packets are getting encrypted and de-encrypted and all. Okay. Local crypto endpoints is 11.1 because between two sites. Okay. I like two sites here. So this is my 11.1 and this is 11.2. So right now I'm on this side. So it's asking who's the local crypto endpoint. It's 11.1 and who's the remote one? Because for site A, who's the remote site? B is the remote site here. So what would be the remote crypto endpoint? 11.2. Okay. These things, so I hope you know the plain text MTU is now 1446. Path MTU would be 1500. IP MTU again 1500 gigabyte interface. This is the current outbound SPI is this one. Have you enabled PFS? PFS will discuss in the upcoming classes. What is exactly PFS is again one more important. But right now you can see guys, what is the PFS here right now? Disable. What is the meaning of PFS? Disable. PFS in short, I'll just explain. In short is what? In phase 1 guys and phase 2. Guys, tell me in which phase do we exchange Diffie-Hellman? In which phase does exactly Diffie-Hellman would happen, guys? Phase 1 or phase 2? Which phase?
Phase 1, sir.
Phase 1. But in the future, if you want to do the Diffie-Hellman, okay, that by default Diffie-Hellman will be there in the phase 1. But in case if you want a Diffie-Hellman for phase 2 also a separate Diffie-Hellman, so then we have to enable PFS and then we have to enable the PFS group. Right now PFS is disabled, so no PFS group has been mentioned here. But in the future, when we would enable PFS for the phase 2, then we have to mention which group of phase 2, like which group of Diffie-Hellman you want to use it. So in the upcoming classes, we'll discuss why PFS or no, not now. But right now, I'm just showing you the feature is what by default disable. N means disable. Okay. Then we have inbound ESPs here. This is inbound SPI, and this is we have outbound SPI. You know, right now I'll just do one thing. This is from site A. This is now my inbound SPI. This is the transform set mode. This is up to here. I'll use it. This is inbound SPI on site A. On site A itself, we have outbound SPI. This is up to here. I have copied and I. This is for site A. Now let's talk about site B. For that, we have to get into the CLI. Use the command show crypto IPsec. So what is inbound SPI we have? This is the inbound SPI we have here. And then what is the outbound SPI? This is outbound for the site. Yes, guys. Could you tell me, is there anything common into this? Because for some concept I have mentioned it here. Is there any something common? You can check it out. Just please have a look on this. Okay, just let me know. What are the common things you can see? Is there any common thing or not? And if yes, so which one? Please take your time and just look at this. Anything, guys, you have observed? Any observation into this output from side A and side B? Anyone? So see, just check it carefully. The whatever the outbound policy is here. This is the outbound policy, is this number here. This is the inbound policy of site A. And which is the outbound policy of site A, okay, the site A, and this is SPI is for the inbound is this. Are you able to see or not? Mathematical concept you can see here, okay. So this is here 8771. This is 8771 here. This is 2010. So guys, when site A, this is we are talking about here. This time we are not talking about anything related to other phase 1. I'm talking about ESP into this. ESP. ESP means, guys, I'm talking about the which phase? Phase 1 or phase 2? I'm talking about the phase 2 here. So in the phase 2, okay, obviously phase 2 is our actual data here. When a phase 2, okay, where is that? Phase, let's consider site A is sending some data, and this data is what? Encrypted here. So this data would be encrypted with the help of what? This outbound SPI. It would take the help of what? Outbound. And when this data would reach to the destination, and after that, the destination, the other side has to decrypt that. So that time, okay, this side would use its inbound SPI to decrypt. So here, what happened here? Encryption. And here, what happened? Decryption. For the same, for the another side, okay, let's consider another side is what? Sending some data. So this would be encrypted with the help of what? it's outbound. This is my outbound SPI. This is what is happening now here, encryption. Okay, and once it would reach to the another site here, then it would use what? It would use this SPI to decrypt the. So what happened? Okay. So when site A would send the data, they would use its outbound ESP to encrypt the data. And when this data would reach to the another site, so the site B would use same like SPI. Okay, it would take the help of same SPI and then it would use it for the decryption. Same on the another end. Okay, for outbound, you're sending the data, it would use what? SPI here, and then same SPI would be what for the decryption. So a question is, Amit, what exactly is like this like SPI is trying to explain here, like why this is here. So see, when this site is sending the data and it's using outbound like ESP, so it means with the help of ESP, it's actually checking its transformation. Okay, which algorithm am I using it? ESP3 dash, ESP MD5. Same on the another side with the same SPI. So the same concept would be mentioned, ESP3 dash and ESP. Okay, same here with the side. This is about inbound ESP. So we have SPI. So this is ESP3 dash, ESP MD5. So we have same ESP3 dash and we have ESP. So the question is why it's not using the SPI of the phase one, which we have already exchanged in the phase one. That is valid just for the phase one. That is not for the phase two. That's the reason ESP and AH header has their own SPI. Okay, because in both the headers we have seen SPI, AH SPI also we have seen in the header, and then we have seen in the ESP also. They have their own SPI because this SPI is going to be held like AH and ESP to encrypt, to decrypt, to for authentication. So not for authentication, that would help into the integrity, which is about hashing. Okay, so this is the meaning of the inbound ESP and outbound ESP. Very, very important for the interview. Okay, so this is very important. So now if I'll be back here, so site A, show crypto IP7. Okay. So this is my inbound SPI, which is going to be used to decrypt the packet when I would receive from the another side. And this is my outbound SPI, which I'll use to encrypt my data here. So in this, we have the concept about SPI. This is the SPI value here. This is the transform set. This is the tunnel mode. I hope you remember in ESP during the in the phase two, during the IPsec configuration, I have told you the transform set has a two mode, tunnel and transport, right? So this is the tunnel mode, right? By default. What is the meaning of transport mode? That we would like on the upcoming sessions, we have a special session for the difference between the tunnel and transport. This is the kind of the internal concepts here, connection ID, flow ID, and all. Okay. So this is the remaining key lifetime. What is the total life? Because total lifetime, as you know, the 1 hour, right? For the phase two. So what is the 3600 out of 3600? How many seconds are pending? 2764 seconds are pending here. Initialization vector we haven't discussed yesterday. Replay attack supported by default, and this is so replay attack also we haven't discussed. So we'll discuss in the future. So this is all about its header. So today what we have discussed about three headers mainly here. One is ASIC-CAM, second is authentication, and ESP. And after that, we have discussed inbound and outbound SPIs. of ESPN. Okay, guys. So now DPD and all is not needed. We can configure DPD also. Yeah, yes, guys. Up to here, is this clear or not?
Yes, clear, sir.
Clear?
Yes,
Okay.
and sir, we have tomorrow class or not?
Tomorrow, no, we don't.
Not okay.
Next class will be on Monday.
Okay.
Yeah. The next and the one small concept here. The next concept is about IPsec over GRE. So do you want me to start it now or in the next class? It will take 14 minutes for me. So if you are okay, so I can start it now. And if you want it Monday, so then we'll continue on Monday.
It's better we start on Monday, sir.
Monday?
Yes,
Okay, what about other students? Yes,
Yes, sir.
others.
Better Monday,
What?
sir.
Monday. Okay, no problem. So this week, just try to practice these things. Okay. The things are mainly is about like GRE and then about IPsec headers. So in the next class, first class would be IPsec over GRE, and in the same class we will talk about DPD. So the next class I'm going to cover two topics here. DPD is kind of dead peer detection. Okay, so instead of the hello messages, we will use DPD's concept. So that is in the next class. Okay, guys. So then see you on Monday.
yes.
Okay.
Thank you, sir. Thank you, sir.
Thank you.
Have a good day.
Amit,
Yes.
I have a doubt. I just want to
Yes,
ensure.
please. Yes.
So in Isaac MP, message 1 and 2, it's all about SS, right? So
Right.
site A and site B will exchange, right? So it's the initiator and the responder router who is going to come to a conclusion that which SA has to be used.
That is as a network admin. Let's consider you
That
Santosh.
control plane, right? Actually, the decision maker.
That overall the based on the router, that would be based on the control. But who is going to be overall decided, who will configure, the network administrator that would decide.
Okay.
So
And I have another question, Amit.
Hmm.
Let's say at site A, I have created 4 essays.
Hmm.
Okay, in a sequence I have created, and in site B, I have created the same exact 4 essays,
With the same.
but sequence is not done. Let's say the sequence is 4, 3, 2, 1. So, on which essay both the parties will
See, first of
negotiate and
all, if we would talk about, let's consider first example. Let's consider on the both the sides will have configured 4 essays. Okay, let's
Okay.
consider it. 4 essays there. So means and you have the same let's your this one Isaac Camp ID, for example. The first example. Okay, 2 example I'll give you. The first one is same. So and all the essays are same. Okay, so then the both the devices they would prefer their first the list priorities are always the highest priority. So which one is the list one for the site A? It would be the one, and same on the another side, which is the list priority, which is the highest priority, 1. List number is equal to highest priority. So if they would give the first preference to the 1. Second scenario, let's consider on the site A you have configured 1, 2, 3, 4, and on another side you have configured 5, 6, 7, 8 here. But on the site A, which is the highest priority? 1 is the highest
1.
priority, and on the another side, which is the highest priority? 5 number is
5.
because 5 is the list number, so they would
Yes.
negotiate on that. So on the another side, that would be 5, and on the another side, that would be the 1. This is the scenario if all essays are same, and in case if all essays are not same, so they would prefer which essays are exactly the same. Okay.
But 1 and 5 essays are not matching here, Amit, because my sequence.
Their sequence number only not matching, but Haggle is matching, right?
No, Haggle is not matching. Just the priority which you said, right? One on site A, 1, 2, 3,
The
4.
first priorities Haggle must be same.
Okay.
Okay. If all Haggles are same, then they would go with the priority concept, which is the number which we have configured. And let's consider if you are saying all Haggle itself is not same, priorities are same, then it's not going to be used anywhere. Because Haggle is their first priority. Haggle means essays inside that.
No, Amit. So 4 essays which I have created, Haggle is matching in both the sides. Okay,
Okay.
just that the priority number that I have used is 1, 2, 3, 4 in site A
So, see,
and in
listen,
site B 4,
what-
3, 2, 1.
just try to listen what I'm saying.
Uh.
Your first condition is essays are same, correct or not? Now we have 1, 2, 3, 4 here. We have 1, 2, 3, 4 here. So these
Haggle is
devices
same.
would decide this. Second, again, we have essay same. Here we have 1, 2, 3, 4. Here we have 5, 6, 7, 8. All essays are same. Okay. Now it would select it's about the highest priority. Highest priority is with what? 1. And here's the highest priority is with 1. This it would select.
In the second example, Amit, so you are considering Haggle is same 1, 2, 3, 4.
Yeah, Haggle is same.
Yeah, but
And let's
in
consider
the
you are
site
saying
B,
uh,
in site B, priority is different. I'm not mentioned it in the same sequence, right?
that's why I'm saying the priority is the second option. The first is Haggle is same. So
Okay.
in this, you only tell as per you, Haggle should be same or not.
Haggle should be same, only then it will
Ah.
form.
Yes, then only this is the priority because they would choose okay, which is my highest priority here, which essay this one, and here is again what this one into this. Okay, let's consider you are saying the same essay I have configured into this. So obviously they are not going to be choose this one. So same Haggle would be what? This one. Yeah, so first priority is always about Haggle. They would compare where is the Haggle is same. Out of these 4, let's consider you are saying in any 2, I have mentioned the same Haggle. Let's consider you have mentioned here in 3 and 4, and here you have mentioned in 5, and let's consider 4 here, for example. Okay. In the both, the Haggle is same, but in another 2, Haggle is not same. So first of all, the router would decide, okay, where is my Haggle same in these 2 essays? Now I'm confused. Okay, which one should I use it? This is 4 and this is 4. So it would use this. But before the priority, again, there is a condition. The Haggle must be same. In case if 3 and 4 is matching here and this is the 5 and 4 matching, so then it won't use the priority. It won't use what? It will use the priority. It would use the Haggle concept.
Yes, Amit, now it is clear.
Okay. Clear? So Haggle is the first option. And in case the okay, but like first of all, as a network admin, we don't configure, but so let's consider if it's there still, okay. So the concept is then after that only priority would. Okay.
Yes, Amit, got it.
Okay. Yeah. Yes. What about other students? Anyone? Any doubt? Any questions? I hope all clear. So shall I close the meeting?
Yes, sir.
Okay.
Yes.
Okay.
Thank you.
So guys, then see you on Monday. Okay.
Thank you.
Thank you. Bye-bye.